Alright, hello. Sorry that you are stuck with me again here as we go through our combinations. Combinations are our 12.3. One of the better proficiency questions they put on there all the time. Alright, so combinations are what happens when order does not matter. You're choosing things or you're putting things together or whatever, but order doesn't matter. It's like you're putting them in a bag or you're just giving them out and the order doesn't matter. So what we have to do is we have to use this formula here. N being the number of things that we have, and then R being our choice number, how many we are choosing. If you did look in the proficiency package before and study that, the formula looks a little different the way they write it in there, but this is the same thing. Alright, so here we got 6 dolls. She's only going to be able to bring 4 of them on her trip. So how many different combinations does she have for choosing those? Now it doesn't matter what order she puts the dolls in her bag to go on the trip, so that's why order does not matter. She's just going to put them in there and take them with her. So our number of dolls is 6. We're going 6 minus 4 because that's how many she's choosing from, and 4 here. So what this is really going to do, we need to make sure we take care of this here and get our 2. So we're going to have our 6 over 2 factorial and 4 factorial. Now again, here is where we're going to want to kind of cut off our top at the same number that we see on the bottom here. So I'm going to go 6 times 5 times 4 over 2 times 1 times 4. I'm going to stop right in the 1 because by now you should know that the 1 is silly and doesn't do anything. So we got 4 factorial over 4 factorial, that goes away. I'm going to go 6 divided by 2 leaves a 3. 3 times 5 makes 15. So 15 different groups of dolls that she can take on her trip. And that's essentially it. We'll write it this way a lot of the time: 5 choose 2. So that means we got 5 things, we're going to choose 2 of them. Here's 5 CDs, we're going to choose 2. Hey, this is one of those proficiency questions. Alright, so we got 5 factorial over 5 minus 2 factorial and 2 factorial. 5 minus 2 makes 3. So we got 5 factorial over 3 factorial, 2 factorial. 5 times 4 times 3 over 3 and 2. So those 3's are going to go away. Plow! 4 divided by 2 is 2. So all that's left is the 5 and the 2. 2 times 5 makes 10. And that is it. Alright, Kathy's got $10. She's going to choose 3 of them to donate to charity. What a nice girl. Alright, so we're doing 10, choose 3. And we're going to go with 10 factorial on the top, 10 minus 3 here, and 3 here. So we're going to have 10 times 9, 8, 7. I'm going to stop there because 10 minus 3 leaves me with 7. Times 3 times 2 times the 1. So my 7 and 7 is going to cancel. 9 divided by 3 I know is 3. 8 divided by 2 is 4. So we're left with 10, 3, and 4. Multiply those together and get your 120 different combinations of dolls that she can donate to charity. That's very nice of her. Alright, so now we're at a theater. We got 12 plays. We need to see 3 of them. Doesn't really matter what order we're going in. We know our 12 is going to be on top. I don't know what this crazy mess is. 12 minus 3 makes 9. So that's why we got this one here. That's our 12 minus 3 part, and our 3 there. Same thing here. We got 5 cards out of 52 possible cards. Looking like this. We got 52 here and here. 5 and 5. Setting it up properly. You can imagine how many different possible hands you're going to have there. That's why poker's crazy. Alright, so here we're just talking about the big difference between our permutation and our combination. Combinations, choosing doesn't matter what order we're going in. We're just throwing them in a bag. You know, it doesn't matter what order your cards are in your hand. You can move them around where you want, right? So order doesn't matter, whereas our permutation, it does. People are finishing first and second, or what order they're sitting on a shelf or sitting in a row. So that determines what type of thing you're going to do. So here Luna's playing her card game. She's got 7 cards. She's got to pass 2 of them. Does it matter what order? No. She's going to give him 2 cards. He gets to look at them. Cool. Alright, so we're going to go with 7 over 7 minus 2 and 2. So we got 7 times, whoops, 6 times 5 factorial over 7 minus 2 is 5 factorial times 2. Got a little ahead of myself there. That is definitely a 6. So my 5 factorials are going to cancel. 6 divided by 2 is 3, and 7 times 3 makes 21. So there's 21 different ways she can pass those cards over. Alright, Joe remembers the digits on his locker are 3, 5, and 7, but he forgot the order. Well, now order definitely matters, right? How many choices does he have for the first one? 3 choices. Once he picks one of them, he's only down to 2 choices, and then once he picks one, he's down to 1. So there's only 6 different ways that his locker combination could be if it's those 3 numbers. Not so bad, he can figure it out. Got 4 books we're going to put on the shelf. Does order matter? Yeah, when you're putting them on the shelf, it matters what orders you're going to arrange them in. So 4 times 3 times 2 times 1, like we've done before, gets us our 24. Alright, and our common CCSD question, we got 5 chips. 2 of them are selected at random. This is the same one we did before with our CDs. We got 5 over. 5 minus 2 is 3 and 2. So that's 5 times 4 times 3 over 3 times 2. 3's go away. 4 divided by 2 is 2, and 2 times 5 makes 10. And we're done. New record. Combinations are easy. Have a lovely day. Make some good choices, and we'll see you.